Hello, everyone. Good morning and good afternoon, and also good evening, wherever you are. Welcome again to the class. This is our second time this week. Okay, and today we are going to be able to cover new topics in our series. And the new topics we're going to cover will be on Boolean logic, on comparison operations. We shall also cover the if-else statement, which we sometimes call decision making. And today the class will be led by one other than Esther Wamboi. Esther Wamboi was one of my students. She started just like you. So that means anybody can do it if you put your heart to it. So Esther started 2020 around November, December, but now she's a fully qualified Python developer. Okay, welcome. And Esther, go ahead and take it away. Thank you.
Okay. Hi, everyone. Thank you, George, for that wonderful introduction. So yeah, guys, my name is Esther. I started off as you guys. Actually, it was just this same class, Introduction to Python, that I started and I was able to learn. So today we shall cover Boolean logic and comparison operators, which is a continuation of our previous class. So I'd like you to tie, as we continue with the classes, these concepts tie in together, like what we learned in class 1, which were variables, data types, and operators, is stuff that is being built up because these are all components of a program, or specifically a Python program. So that said, I would like to just ask you guys a question, because we all think that we were studying programming. So I'd like someone to tell me what a program is. Who can tell me what a program is?
Hello?
You can type in chat, or you can unmute yourself and speak. Any can do.
All right, I'll go ahead. A program is a set of instructions that is written to the computer, which is carried out.
Yeah, that's good. That's good. Yeah, a program is just a set of, as you've just categorically mentioned, that it's a set of instructions that you give a computer to perform a specific task. And a program contains, let's look at programming in a practical way. Like it has ingredients, like when you're making a recipe. So the ingredients would be things like the data types or variables that we learned in the previous class. And also it might be directions, like when you're told boil this way or cook it this way. So those would be now the instructions or the directions that you tell the computer, do this. So for this class, we will look at now those directions that we give our computer. The previous class, we learned about the ingredients. That's why we had to start with the variables and data types. Because now when you're cooking something, even when you read recipe books, it always starts with ingredients. Then, like when you're cooking something like pilau, you'd have rice, you have garlic, ginger, tomatoes, all the ingredients and the spices. And then below the ingredients, we have now the directions of how to cook them. So now we want to see how variables and data types can be used together. And for now, for those whose who it's the first time to like do any kind of programming, you started by executing Python code line by line. So we know that the Python is an interpreted language, and each line of code is executed during runtime. So we want to see that there are other ways, but that is how any interpreted language is executed. So I just wanted to, I've just had given you a brief description. So in mind, think of Boolean logic or if statements as something like even as a day-to-day thing. So as we continue, you'll be able to understand why I have started with that whole intro there. So we continue. So we have Boolean logic or Boolean logic, depends on how who your English teacher was or how you were introduced to the word. So this is a mathematical, I believe it's a mathematical concept, and it checks on the truthiness, so how true a statement is. So as a statement can either be true or false. Like there's never, even when you're talking, even when I'm talking to you, I'll either tell you something that's true or I'll tell you a lie. There's never a T. You know, there are people who say not saying the truth is like not saying something is equivalent to like being it's good because you have not lied. But I don't believe in gray. It's either white or black. So it's either true or false. So that's the Boolean. And most of the times when you're writing a program, you will use a lot of Boolean logic to execute your code. So two of the most important areas where we use Boolean logic is where we want to write an if statement, which we shall learn today, and you want to have a condition that would you want to use, you can use Boolean logic as the condition of an if statement. Also, there's also something known as regular expressions, or when searching, even when searching on a browser, you can use Boolean logic either to narrow down your search or to broaden your search. So we will see, and I think even sometimes we use it knowingly or unknowingly. So that's where we use Boolean logic. So, and more often than not, we use Boolean logic with either comparison operators or logical operators. So who can give me an example of a comparison operator? Example of a comparison operator?
Can use, my name is Martin. If,
yeah.
Then yes, if and then else.
A comparison operator. Martin, you said,
just remember comparison is to compare things, like can compare one thing with another. Let's say apples and oranges.
Yes, okay, if and then you will use equals. Let's say
equals. Okay.
Yeah.
Oh, sorry, I hadn't seen the guys who had posted in chat. Yeah, Caroline and Gideon, your answers were also correct. So Martin, you said that equals is a comparison operator. So what does equals do?
Here comparing let's say two variables, whether they equate the same.
Whether they're the same. Yeah,
yes.
That's correct. That's good. Yeah, thanks, Martin. Who else has an example of a comparison operator? We learned that in the previous class. We learned types of operators. We can write in chat or so
Or?
See, or, okay, or is an operator. I don't think it's a comparison operator, but it is an operator and we use it in Boolean. Thank you. So let's try and revisit some of the operators that we learned. So we have comparison operators. So as Martin told us, we have equal, equal. This compares whether two variables are equal to each other. And always remember, there's a difference between one equal sign and two equal signs. Who can tell me, who has an idea? What's the difference between one equal sign and two equal signs?
One equal sign is to assign a variable or a data. Yeah. One equal sign is to assign a variable and two is to compare.
Yeah, great. Yeah. So one, and I always make that mistake sometimes. I'm writing code nicely and then just write one equal sign and I'm like, yeah, why is my code not working? So always pay attention to such details. One equal sign means that you're assigning a value to a variable. But when you have two equal signs, you are comparing two variables or two values. Then when you have an exclamation before the equal sign, or bang, it's an exclamation, or you can hear some people saying bang, it states like the reverse or the opposite. So it is not equal to. So you're comparing whether two values are not equal to each other. Then we also have greater than sign, less than sign, greater than or equal to, and less than or equal to. So those are comparison operators. So these are operators that compare two variables. Then now there's someone who told me or. So or is a logical operator. Or is a logical operator. So in Python, we have three logical operators. We have and, or, and not. So and returns, you remember we said a Boolean logic can either be true or false. So these logical operators also compare variables. However, they use logic to compare these variables. So if both, like let's say we have we are comparing oranges and oranges. So we have oranges on this side and oranges on this side. So if those two variables contain oranges and we say and, it will return true. However, if we are comparing oranges and apples and we say and, it will return false. So and operator returns true if both statements are true. For example, you can also say, let me say this. When we've all African homes. When we were growing up, we were always told that your parents should not reach home before you. So if your mom arrives home and you want, say, to go and visit your friends, so you know that when your mom is home, you cannot visit your friends. So if you're saying, so the fact that she is home and you cannot visit your friends, so if I am at home because my mom is home, that means those two statements are true. So if my mom is home and I'm not visiting my friends, that's true. But sometimes we have moms who are like, okay, it's okay, you can go say hi to your friends, but so long as I'm home, but don't stay too late. So your mom can be home, but you are visiting your friends. So one statement is true, she's home, but now you have the chance to visit your friends. So that is false. So long as one statement is true and the other is false, or will always return true. So the difference between and or is that with and, both statements have to be true for the true to be returned. And with or, one statement, it's not a must for both statements to be true. So long as there's just one statement that's true, a true will be returned. But with not, it's like negates. It negates whatever you have. So if the value is true, when you say not, maybe not, it's like you're saying not true, it will be false. So I'm speaking a lot of words, and I prefer it when someone does it. So we are going to do it practically so we can see how these Boolean operators work. So you can now, so far, does anyone have a question? Any question? Give me a second. So we do not have a question so far. So I'll be the one with the questions. So let me share my, I'm writing my code on Google Colab. So now we are now to the coding bit of it. Hope everyone can see my screen.
Yes.
Okay, great. So if I have x equal to 5, y equal to 10, and 7 equal to 11, when I print x is less than y, what is the expected output? Who can tell me what output I'd get from this? If I print x is less than y. So is x less than y? First of all, let's think of it this way. Is x less than y? Who can tell me what output I'd get?
Should be true.
Great, yes, let's see. So that's true. So the output of a comparison any comparison operator should be either true or false. So we can try with a different operator. Say maybe let's check whether x and y are equal to each other. So equal, equal. This should be false. So the output of comparing two variables can either be a true or a false. So let's see if I say is x not equal to y. This should be true. So comparison operators work in this way. So when you compare two values, it can either be true or false. Those are the only outputs that you get if you compare two variables using a comparison operator. So now, in addition to that, what we do is most of the time we combine comparison. We can, not always, but sometimes we use comparison operators and the logic operators to get a particular output. For instance, here we have the same values, x equal to 5, y equal to 10, and 7 equal to 11. So the first one I want to print out is x greater than y and y greater than z. So remember we said AND operator returns true when both statements are true, only when both statements are true. However, when one of the statements is false or all the statements are false, and operator returns false. So now let's think before we give our output. X greater than Y, that is false, right? So we definitely know this one will just be false because it's already false. Y greater than Z, that's false. So these two are false. So we expect a false. Then we go to our next one. X greater than Y, that's false. So we expect a false. Y less than Z, that's true. So well, let's see, this one has a true here, but has a false. But we said, so long as there's false, and will never return true. And we check X less than Y. Yeah, that's true. Y greater than Z, that's false. Then we check, is X less than Y? That's true. And Y less than Z, that's true as well. So we only expect to have one true. The last one is the only one that we expect to return a true. So as you can see, our output, the last one is true. Why? Because it's the both statements are true. However, in case there's any false in a statement, the AND operator will always return false. In contrast, we have an OR operator. This is the exact same code, but now I changed it and we used an OR operator. So an OR operator, so long as there's a true somewhere, it will return true. So long as one of the statements is true, it is always going to return true. So for instance, the first statement, we check, is X greater than Y? It's false. Is Y greater than Z? Is Y greater than Z? True. No, false. So both of these are false. So there's no true here. So we expect it to return false. Is X greater than Y? No, that's false. Is Y less than Z? That's true. So because there's a true in this statement, we expect that the OR would return true. X less than Y, that's true. Is Y greater than Z? That's false. But since we have a true statement here, we expect OR to return true. Both of these two statements are true, so we expect true. So the only false statement that we have would be this one because both statements are false. But wherever there's a true, if you have a true and a false, or when you're using OR, it would return true. Then we have a NOT operator. The NOT operator basically negates. So, and also to mention, you see here, I have assigned the value true to X. So you can always assign either true or false to a variable. You can say X equals to true. So this is a value true. We have assigned true to X, and then we have assigned false to Y. So in Python, we can assign either true or false to a variable, or we can use true as a value and false as a value. So if I print not X is the same as I'm saying print not true, which is the same as false. Print not false is the same as printing true. So far, any question so far, or is anyone lost? You can tell me so we can find each other, we can go together. Any question, any part that wasn't clear so far? Okay, I think that part was clear. So that's Boolean logic. So there's some few Pythonic expressions that we use, and I thought it would be nice to know, because sometimes you'd see code written this way and you'd be like, so what is happening here? So remember, initially we said x less than y and y less than z should return true. Sometimes when as a programmer or when you're writing code, sometimes it gets boring when you keep repeating yourself. Like I wrote x less than y, and then I wrote again y less. So sometimes with Python, you can, because Python can change this with and, it can change the two values because there's y, there's a common value between these two statements. It can change this into one statement. So x less than y and y less than z can be also written as x less than y less than z. This is in Python, because if you'd write this in a different language, the output would be a bit different. So this is a concept in Python, because x less than y less than z is also interpreted as it first checks x less than y, then it goes again and checks y less than z. That's how Python works. So this is a concept. So sometimes when you're writing code, it's cleaner when you write the second statement than when you write the first statement. Like this is like a better way of writing your code. So we can just confirm and see whether both of them would return true. So these two statements are the same. So with Boolean, there is also a function in Python known as bool. So bool is just the same as Boolean. It just checks whether something is either true or false. So for example, and also in programming, or when you're, in programming as a concept, any value that's not a 0 is always true. 1 is true, 100 is true, -2. So we'll confirm and see. But anything that's a 0, anything that's 0 is false. Like it's nothing, so it's false. So when we can use that by using the bool function to check. So 1 is true, 0 is false. So I can even write, let's say if I write a different number, see, it's true. I can even add let's see whether negative values are true or false. So negative values are true. So any value that's not a 0, even I think infinity is true. Let's just confirm. Infinity is like it's a mathematical number. So infinity is also true. So whatever the values, like 0 is false. I know of none being false. So there's also, you can also have a value like none. So these are keywords, and you can, I think it's capital N. None is also false. So sometimes even like we might get values like infinity or some, when you're working with big data sets and you're trying to calculate, you might get infinity and stuff like that. None means that that value does not exist. It's not there, none. 0 also is false. So none and 0 are false, but any other value, any other number is true. So we can also see when you have an empty string, when you have an empty list, an empty set, any data type that's empty, any data type that does not like have any value in it will always be false. So as you can see, all of these are false. So I've basically tried to cover Boolean logic, and I've tried to cover areas where we would see Boolean logic in action. And if you haven't understood the concept, or if maybe there's something that skipped past you as I was talking, you have any question, anyone? Anybody with a question? Also, chained. So, Caroline, when you ask chained means that it's like, you see the way a chain is interlinked. So you can, when chaining means that I have linked the y here, when I say x less than y and this other y, I've linked the two, these two y's, I've linked the two into one y. So now I've chained, so I've commented this and said this is now a chained comparison statement of comparing x less than y, y less than z. Any other question?
Yes. Can you chain an or statement?
An or?
Yes.
No, because you see an or statement, you see this other side might be false and this other side might be true. So we can only chain an and statement because both statements are true. Because now if I was to chain an or statement like this, if this was false, it would not make sense if I put them together. I don't know if it's clear.
It's clear.
It's clear?
Yes, it is.
Sure. Okay, yeah. Sorry about the noise. Any other question? Okay, so back to our PowerPoint here. So we have control flow. This is control flow in programming. Sorry? So I kind of like mentioned this time and time again when I was talking about if statements and stuff like that. So I said that a Python code is interpreted line by line, line by line, line by line. But sometimes even in life, like life does not go like the way you want it. Like you don't, there's no, if life was like, there's a manual written, I grow up when I am 3 years, I do this, when I am 5, I do, like everyone like follows the same path, like life would not even be interesting. So even code sometimes, you know, when you write, for me, I write code that mirrors somehow reality. Code is mathematical and should also mirror our day-to-day lives, and that's how I interpret code. So sometimes you reach a point where you're writing a program, and you're writing a program for people, and people always need, even God gave us the ability to choose. So you reach a point where you have to make a decision. If this is this, I think I need to do this, not this. So this is where now we use if statements or decision. This is now decision making in programming. And each programming language has its own way of showing decision making. And if statements will always be there in any programming language. So there are 3 things that a program, for a language to be known as a programming language, it has to have the ability to have loops, to have if control flows, and to also have functions and variables. Those are concepts that any programming language would have. So, and if statements like use the Boolean logic to make decisions. So most of the time you find that you give an if and say the condition. So if a condition is true, you then run code. If it's false, do something else. So that is why we had to start by understanding how does Boolean logic work, so that we can now understand how if statements work. So if statements basically are the decision-making part of writing your code. Okay. So let's go back to our code. So I have an if statement. So sometimes I like using real life scenarios. So for our if statement, think of how you were graded in school, or think of how when you're doing an IT exam, any exam that you do, you can either pass or fail, right? For instance, we have a score variable here, and we want to use an if statement. So first, let me comment this out. So for commenting in Python, you use the hashtag or octotop. Yes, I know it's some people call it an octotop or hashtag, whichever you want to call it. And this would also make the code inexecutable. So I won't be able to execute this code. So I want to say if the score, so now you can see why we had to learn about the comparison operator. So I want someone to just, sometimes you can always think out loud your code, and then now you can write it. That makes it easier when you're writing code. So if someone, they scored an 80, then you say if score is greater than 70. So I want someone to tell me if the score is 80 and the comparison operator is score is greater than 70. Is that true or false? Will the condition be true or will the condition be false? Will the condition return a true or will it return false? If I scored 80 and then someone said, if the condition, if your score is greater than 70, you do this. So will it be true or false?
Neither.
Neither. Why neither?
Because the score hasn't been, okay, because on the second line where the condition is set, it doesn't match the variable.
It doesn't match. Okay. I like your train of thought. Someone else with a different school of thought. I see someone has said true. Someone else, I'd like a third person.
It's true.
True. Why?
Because the comparison is greater. So
because
the square is greater than 70. So it's true, it's greater than 70.
Okay, yeah. So there's someone who said they're different. And that is very true. 80 and 70 are very different. But now we come and check what is the comparison operator here? Greater. So 80, so we replace this variable score here. If I was to write, this score represents 80. So is 80 greater than 70? That is true, okay? So always keep in mind, always remember to check your comparison operator. So, and then you always replace the value of the variable with the value. So if score is 80, so here I called score. So I will replace score with 80. So then I come and see, is 80 greater than 70? So it's true. So with an if statement, when a statement or when the condition is true, it always executes the code that is inside the if state or the if block. And now here comes a concept in Python. Indentation is very important. What do I mean by indentation? Indentation is like the paragraph. So when I write my code this way, let me try and run it. You can actually even see it's been highlighted. It gives me an error. And what does the error say? Indentation error, expected indented block. So anytime you write an if statement, always make sure that the code you want to be executed, so you write the if, then the condition, a colon, then whatever code you want to be executed in the if block needs to be indented. You can use a tab or 4 spaces. Do not participate in that argument, or whether it's 4 spaces or tabs, but you can use either in Python. So once we do this, let's try and run our code and see if this is true, it should run this code. You see now it has printed, congratulations, you passed. And what happens is if there was code beneath it, it would now continue. So let me uncomment my code here. If there was any other code, because most of the times you find that you have like 1,000 or so many lines of code, and then you have your if up in the middle. So the other lines of code will continue running. Like as we said, Python code is executed line by line. So our if statement would be executed and the line below would also be executed. Let's assume that I got a 40. Let's assume I got a 40. Who can tell me what is expected from this code?
It's false.
It's false. That's great. Yes, it's false. So what output do we expect? You can tell me like this. What statement will be printed? Is it congratulations, you passed? Is it continue, execution of program? Is it both statements? Is it nothing? Sorry, you failed. Sorry, you failed. I don't see a sorry, you failed here in my statement here, this statement.
I think it will bring up an error of some sort. Yeah.
An error.
Yeah.
Okay. So someone said, sorry, you failed, an error. So let's run it and see. So it prints out continue execution of the program. So with an if statement that just has if, it will print out whatever is in the if block if the condition is true. If the condition is false, because now it's false, it will skip whatever is in the if block and continue running the program. There won't be an error because we said we are always given a choice. So if it realizes, okay, this person, their condition is false, fine, it doesn't want me to run whatever is in the if block. Let me just go on with normal programming. So it will continue to the next line of code. Okay. But sometimes, someone read my if else statement. Sometimes when we do exams, you just want, even if I failed, just, you can imagine if you did an exam and then like you submit, maybe you're doing it online and then you submitted and then you're expecting like to be graded or something. And then nothing happens, like it just shuts, like the program ends like that. You don't know whether you don't even know whether you passed or failed or anything, just keeps quiet. So this is how this if statement is like, because it will just continue. It won't tell you whether if I get a 40, it won't do anything. So that's where we have another statement we call if else statement. So the if else statement, it gives room for the case where the condition is false. So in this case, we saw earlier that if I score an 80, and the condition is that if the score is greater than 70, I say congratulations, and then I continue running my code. So let's run it first when the condition is true. So when the condition is true, I will be told congratulations, you passed. So let's say I scored a 40. Let's say I score a 40. What happens is now the else would now be executed when the condition is false. So when the condition is true, whatever is in the if is executed, whatever is in the else is not executed. Else, now it skips else and then goes on to the next line of code. So if it's true, it only prints whatever is in the if, only the if. But if it's false, is when it is going to print the else. Okay, and take note. I just want to remind you of the syntax. We have if, the condition, colon, ident, whatever code you want to be run, then now get out of the indentation, because when you stay inside this indentation, it means it's still part of the if, but the else is not part of the if. So that's why we now say else, full colon, the code that you want to be executed, and then you exit the indentation. Some programming languages would have brackets and semicolons. If you've written JavaScript or C or whichever the coding language or programming language, the syntax would be different. So here I'm highlighting the syntax of an if else statement. Okay. So sometimes, so this is so we've covered the if statement, we've looked at the if else, then we also have, sometimes you can give people options. Like, it's not always pass or fail. Sometimes, we are all not equal. So sometimes we get different grades, like, the way you can have an A, a B, a C, a D. So if someone gives you that program, like maybe you're creating a testing system and the person wants, I want a graded kind of thing. Like I want to give me grades for my students. So how would you create that program? So the program would have another additional keyword, which is known as the elif. So the elif we always have to start with if. So we say if score is greater than 80, print this. Else, if, let's give room. Else, if the score is greater than 70, do this. If it's greater than 60, greater than 50, do this. So we give elif. Elif like gives additional conditions. So one thing I would also like you to put in mind is that code in Python works logically, like line by line, line by line. So for instance, if someone scored 80, it would come and check the first condition. If score is greater than 80, greater than, or now I've used a different operator. So who can tell me, if I say greater than or equal to 80, will it be true or false? So someone scored 80. So is this true or false? Is 80 greater than or equal to 80? True or false?
True.
True.
True, great. So it is true because now we have the greater than or equal to. So this print, you scored an A, should be our output. So you scored an A. So if someone, who can tell me what will happen if, say, someone scored 76? If someone scored 76 and this is our code, what will happen?
It will print a B.
Yeah, so whatever would be executed would be scored a B. So we notice that with if and elif, the code, it first comes, it checks this first if. So if this one is false, if you're working with 76, the first if score is greater than or equal to 80, it is false. Then it goes again to the second L. Now to the first elif, it checks. If it finds that this is true, it executes this and exits everything else in the if block and goes to continue now with the other code. So that's how it works. So let's say if you have something like, we change this to another value, maybe we say 56 is greater than or equal to 50. So this would be, you scored a D. So it goes and checks, is it 80? No, that is false. This one for 70 is false, for 60 is false, for 50 false. So what if someone scored a 10? So if someone scored a 10, it will go and check everything else. And then if it doesn't find anything, it goes to our else because everything else is false. So anytime you have an elif, make sure you have the if, the elif, and the else statement. So that is how you work with if, elif, and else. Any questions?
So in our program, and in this case, we have an end.
Sorry, I don't get you.
Like in some programs, if you have the if statements, it ends with the close with the.
It ends with what? You're breaking up a bit.
And if END.
I'm not getting you. Is it possible to type the question in chat, or maybe your connection?
Yeah, you have a bad connection. Can you type it? Type in the chat so we can answer it for you.
Any other question as he types?
Does the order matter of the way you have placed your statements?
Yes, it matters. But it might not, it depends on the logic that you're using. Because sometimes when you let's try. Sometimes I always try and see. Let's maybe disarrange and we put 70 here. Okay, so we've interchanged 60 and 70. And let's assume someone got. So in our logic, we're trying to say if someone got greater than 70, they should score a 60, a C. And if they scored greater than 60, you want them to score a B. Is it this way, or you want us to interchange? Okay, let's say, should we interchange even the B and the C, according to you?
Yeah, yes, interchange also the B and C.
So we want to see whether when someone maybe scores 76, right? To see whether they will be given a B or a C.
Yes.
Okay, so now let's run our code. You see, scored a C. Do you know why that has happened? Remember we said it checks step by step. So once it finds that one statement is true, it won't even bother with the other ones that are below it, because now it already came and checked. Okay, 76 greater than 60. It's so it's C. So it won't bother to check this 70 part. You get?
Yeah. Yes.
But sometimes it might not be mathematical like this. It can be something else, and that in that case the order won't matter. You might have a case where maybe you want to check whether, let's say, we can just write. Let's see. Can just add code here. Just a simple code. Let me see here. So maybe we have, let's say we have gender. Say, let's just say, maybe you want someone to be female. Okay, let me I'm not so creative when writing code on the fly. So I would say if gender equals to maybe, let's say male, and maybe you are maybe Elif gender equals to female. I print then you can see L. Maybe it was a survey or something. You can say no value entered. So in case we have such a program, if we interchange this and this, there won't be a difference. So it will also, if let's say I interchange, okay, let me just delete this. And if I interchange them, and then I put female at the top, we still get the same value. So sometimes that's why I say when you're writing code, take a bit of time and think of how you would want your code to execute. You know, if it's something like this, even if I exchange my if statements, it will not make a big difference. But if I'm writing code that it requires a lot of mathematical, arithmetic and stuff that would interfere with the values and stuff, like now my grading system, it would have an impact. So sometimes you'd rather work with writing your code. Before writing your code as code, write it in what we call pseudocode, which would be like write it out in English. Write out how you would want your code to run in English first. Then you can now run your code.
That's correct. I'm sorry, just to interject. Also, before you write a code, it's almost like you're planning to go for like a shopping, let's say to a supermarket. So you write down a shopping list. That way you don't forget. And most of the time, you probably want to write some of the very basic things you want to get fast, right? For example, you want to go buy milk, you want to buy sugar. So that sequence is very important. When you don't write it, you will most likely find out that by the time you get back home, you just forgot to buy, for example, one of the most important things. And the same applies to if you want to cook for your guests. You probably have, some people don't, but some people know it often. You probably want to have your recipe really noted down. That way you don't mess up. If you mess up, then it's not going to be good on you, right? So the same applies to programming. You put those instructions sequence by sequence, like one word after the other. And when you do that, that's what we call pseudocode, or we call it algorithm. So you write it in basic English. Say, for example, you want to cook ugali. So you have to make sure that you actually have fire. So either jiko, or you have gas, what they call meko in Kenya, or you probably have kuni. Whatever you have, it has to be there. And if it's there, is it available to use? If it's kuni, if it's wet, you cannot cook. So that set aside, then you have to look for a clean sufuria. If sufuria is not clean, then you have to wash. Once you wash that, then you put the ingredients together. So you pour the water, make sure the kuni or the jiko is lighten up, and then wait for the ugali wait for the water to boil before you start cooking ugali. Otherwise, you'll not be cooking a good ugali. And that's the same thing applies to programming. It's a step-by-step process. Take, for example, you want to add two numbers. First of all, you have to know that you have to declare a variable. So if two numbers, then you have to declare first variable and then second variable. And then you add the two variables, and then you store them in the third variable. And then in order for you to be able to finish, you have to print it out so that you can see the results. So you print the third variable, which is the result. So it's a sequence of events. Okay, go ahead, Esther, sorry.
Nice, okay, yeah, thank you for the explanation. So I think that is clear. I hope that's clear. Then this, yeah, now I get your question. He was asking whether there's an end if there's an end. I have not seen that. Maybe if George clarify if we can do end if.
What was the question?
If there's an end if statement in Python, like one to end the.
No, actually there are different languages, and most likely you must have heard or you must have done that in a different language. But in Python, we just have the if else, and then we have the if else if. If you go to C or you go to Java, those are also have their own constructs. And then some languages you have to end the end if. So in Python, we don't have it. But does not necessarily mean it's not going to be there, because the languages, just like Python, all these languages revolve. They keep on changing. Each version come with different, let's say if a lot of people in the community start asking for, let's say I've been doing a lot of programming in Java for a long time, but I would like to switch to Python. And I can go into the community and keep on asking for a feature which I thought was very good in Java. And long and behold, the creator of Python might just decide to say, hey, in Python 11, we are going now to have this. For example, there's something we call the switch statement. The switch statement is just the else if statement, but it's available in Pascal, it's available in C, in C++, in Java, and most of these languages, including JavaScript, but it's not available in Python. But you'll find that in Python 10, I believe, it's now actually a feature. So things change, but right now it's not yet there. But if you want it, you can have it, because the beauty with programming in Python is you can bend it the way you want, because Python can talk with any language like C, C++, and it can also even talk with Java. So Python is very powerful, so you can bend it. If there's a feature which you don't have, then you can call a library from another language like C or C++ or even Java to incorporate it in your software in Python. Did that answer your question?
Yes. Thanks.
Okay.
Okay, that's great. So I think that summarizes today's discussion. But there's this task that I have here. and I'd like us to do it at our own time. But before like we go do it, I'd like, because we've been taught how to write pseudocode or how to think in terms of pseudocode, we can try this. So the task is to create a program that asks a user to enter a number, then evaluates whether the number is even or odd. So I'd like you to think, so if you were given this kind of problem, how would you go about it? Not even in terms of programming, like I ask you, like, how do you check whether a number is even or odd? So someone can someone like run us through maybe the kind of pseudocode they'd write? Okay, I can start off maybe. So for me, what I'd know, because now the question I've been told needs to ask a user to enter the number. So the first thing would be to get the first thing for me would be to get the user input. Once I get the user input, maybe who can tell me what next?
So once you get the user input, you have to interrogate that input. For example, if you know in life, anything even has to be divisible by 2, right? So you ask yourself, whatever you put in, is it divisible? Can I divide it by 2? And if I can divide it by 2, then the remainder has to be 0. If that happens, then it's an even number. Otherwise, it's not. And that's it.
Wow, simple. So you check whether the input. And who can tell me what operator can I use to check whether a number is divisible by 2?
In Python, right?
Yes. How can I check whether a number is divisible by 2?
Come on, guys, you've been reading this. We did it even last video last week. If you've forgotten that, it's okay. But do you remember the operator known as modulo? It's like a percentage sign on your keyboard. Any number you divide by that, or any number you perform that operation on, if it's not having a remainder, then that number will automatically be even. Otherwise, it will be odd.
So this is the modular sign. This is the modular sign. Oops.
Shift 5.
So let's say maybe we want to check whether 4 modulus 2, we expect it to be.
So we probably want to save that output in a variable that we interrogate. Yeah, so that's good.
So okay, let's write out this. So I think we
It's okay. No hurry.
Can you go on? Okay, fine.
It's okay.
So let's write out our code. So first of all, we've said
can use the input statement so that we have a full code.
Okay. So maybe we'd say So we get the input statements. So maybe we could say enter on number. So, and one thing we have to note is when we get the input, the value would be stored as a string. So we have to convert a string into a number. So most of the time, what I would do, I would convert it into a number using a typecasting function. What's happening here? Oh. My code is correct. So I could convert it directly on this code, but for just purposes of writing our code, we can now assign this variable again. And we say, I want to convert it into an integer. So this function takes in input or takes in a value and converts it into an integer. So now you see we've used the variable. So I've gotten the user input, and then now I want, because the input would be, well, yeah, the user would give me a number, yes, but the number would be stored in a string. And this is because, as you can see, the input, any value that you enter is always in quotation marks, and anything in quotation marks is a string. So I convert it into an integer. So now we have a value that the user enters. So now we go and now write our if statement. So we said, our if statement starts with if the value now that I have then we use the modulus 2 equals to 0. Then I can say print maybe we can say that number. That the value of that number, and then can say is even. So if the value that the user enters and I do a modulus 2 on it, if the answer is 0, even before that, sometimes if the user actually enters a 0, so for me I can start off by saying maybe if because you always know, is 0 even or odd? Can't tell me, 0 even or odd? Okay, I think 0 is even. So I would first of all check for the 0, just so that my program works a bit better. So I'd say if the number the user enters is 0, I would say 0 is even. And then now I wanted us to use the elif. So I can say if the number now is not 0, if this number modulus 2 is 0, it will still be even, then I can say else and just copy this. So here is my program. Yours might be different, but this is how I'd write it. So I would get the user input and then convert the input into an integer, and then now use an if statement. So if the input that I converted is 0, I'd say, it depends on you, I say 0 is even. Or instead of saying 0 is even, I'm not sure whether 0 is even or odd. Can't remember my math. So let me just say it's 0. Then if the number entered modulus 2 equals to 0, we can say that that number is even. Else, if it's not equal to 0, we can say the number is odd. So now let's try and run our program and see. So now I'm told enter a number. Let me enter 6. Enter. So it tells me 6 is even. Let me run it again and try an odd number. Let me say 3. So if I say 3 and enter, 3 is odd. Let me try my 0, the 0 that I insisted on writing. 0. 0 is 0. So basically, we've just created a simple program from pseudocode. From the pseudocode. So this is how you think of how to write a program. You just write the pseudocode, then try and with this pseudocode, it gives you a rough idea of how your program would be. So this would be the program. Any questions? So yeah, I will share the slides. I will also share this notebook on Google. It's on Google Colab. I can also share the notebook with the code as well as the slides. So yeah, I think that's it for today's class. Any questions, any comments, feel free to share.
Yes. How is everybody feeling after this long class? I just want to reinforce the fact that if you're encountering any difficulty, just know that any beautiful thing does not come easy. And if you have any question, we are always available and we'll be more than glad to help. So it's a journey and success doesn't come overnight. If you keep on putting your effort into this, then you're going to see the end. You're going to see a light at the end of the tunnel. So having said that, we also thank you very much for coming. And tomorrow we have our last session of this class as in the Zoom, but the class will continue going on. We wanted just to make sure that we introduce you to the basics, but everything else will now be just on the WhatsApp, and we will be sharing a lot of codes as we work together. So it's your chance to don't be afraid and don't shy away to ask any question. No question is stupid question. If Esther started, she did not know anything. Esther, if you allow me to say, and that was 2020 at the peak of COVID. So Esther now is able to teach not only Python, she's also teaching JavaScript. She's teaching CSS and HTML. And normally all it takes is just to be able to identify what you need and go for it. Okay. Thank you again. And that's all for this class for today, and you all have a good day. Thank you.
Thank you.
Thank you.
Have a
Thank
lovely
you.
day too.
All right, bye.